Hybridization, mixing of two or more atomic orbitals to form a new set of equivalent hybrid orbitals. Means you're mixing different atomic orbitals. For example, you're mixing orbital S and orbital P, and it will form a new set. That new set is called hybrid orbital. Not S, not P. It's another name. Number of hybrid orbitals obtained equals to the number of atomic orbital mix. For example, you mix one S orbital with two P orbital. S plus P plus P. So you are mixing three orbitals. The hybrid orbital will form after mixing S, P, P. The number of hybrid orbitals are 3 because you are mixing 3 orbitals initially. So the total number of hybrid orbital will be formed after mixing them is 3. The spatial orientation of the new orbitals is called more stable bonds. Why the hybridization happened? Because the new orbital is more stable bond and consistent with the observed molecular shape. Next, type of hybrid orbitals obtained varies with the types of atomic orbital mix. So, the type of hybrid orbitals depends on the types of orbital mix initially. When you mix S orbital, one S orbital mixed with one P orbital, the type of hybridization is sp hybridization. When you mix one S orbital and two P orbital, the type of hybridization is sp2. When you mix S with three P orbitals, the type of hybridization is sp3. When you mix one S orbital, 3p orbital, 1d orbital, the type of hybridization is sp3d. And if you mix S orbital with 3p orbital and 2d orbitals, the type of hybridization is sp3d2. It depends on the number of p and the number of d you use. That is the type of hybridization. So these are the types of hybrid orbitals. Example, S orbital mixed with P orbital. This is the shape, sphere shape, mixed with dumbbell shape of P orbital. Do the hybridization and it will form like this. This shape will be formed when you mix S orbital and P orbital. 1, 2. And when you combine them together, because you have one S orbital, one P orbital, so the total number of hybridized orbital must be the total number of initial orbital that you mix. You have one S orbital, one P orbital, so total number that you mix initially are 2. So the number of hybridized orbital must be 2 because you are mixing 2. So the result will have 2 hybridized orbital, this one and this one. When they mix them, this is the final hybridized shape of sp orbital. 1, 2. You don't draw them separately. This is how you draw 2 sp orbital. 1, 2. You mix them. Still, there are 2 sp orbital, not 1. The shape is like dumbbell P, but this dumbbell P only 1 P orbital. This hybridization sp is counted as 2 because initially you have 1 sp, another sp, and this is 2 sp orbital. Hybridize to form 4 sp3 orbitals. So you're mixing S orbital and 3p orbitals, and it will form 4 because you have one. Initially you have one S orbital, one px orbital, one py orbital, one pz orbital. When you mix them, there will be 4 hybridized orbitals, 4 sp3. 1, 2, 3, 4 of them. But you don't draw them separately. There are 4 of them, but you don't draw them separately. You draw them in one. So it's 1, 2, 3, 4 sp3 hybridized orbital. And this is the shape of tetrahedral. If you look at the angle, it's tetrahedral angle, 109.5 degree. 1s orbital, 2p orbital. So you have 3 total types of orbital here. If you have 3 total types of orbital, the hybridized orbital that you will get is 3. When you hybridize these 3 orbitals, they will form 3 hybridized orbital, 1, 2, 3, but you don't draw them separately. You draw them together, they are shown together. 1s orbital, 2p orbitals, it will form sp2 hybrid orbitals. So 3 of them, 1 sp2 hybrid orbital, 2 sp2 hybrid orbital, 3 sp2 hybrid orbital. So there are 3 sp2 hybrid orbitals drawn together. Okay, you only show the large lobes. This small lobe part, you don't show it. Just draw the large lobe part in drawing hybrid orbitals. And if you look at this is the angle between them is 120 degree, 120 degree. Determining type of hybrid orbital. First, you have to draw Lewis structure and then predict the electron group arrangement. Before that, you have to predict the electron group, then predict the electron group arrangement. And then you look at whether it has, the central atom has lone pair or not, and then you determine the molecular shape, so deduce the hybridization of the central atom, and then draw the hybrid orbitals. That's how you determine hybrid orbital types. For example, electron group 2, electron group arrangement linear because electron group 2, sp hybrid orbital. If electron group 2, electron group arrangement linear, it's sp hybrid orbital. If electron group 3, trigonal planar, sp2 hybrid orbital. Electron group 4, tetrahedral, sp3 hybrid orbital. Electron group 5, trigonal bipyramidal, sp3d. Electron group 6, electron group arrangement octahedral, sp3d2 hybrid orbital. And the angle follows the name. Follows the name of electron group arrangement. If linear, 180 degree, trigonal planar, 120 degree, tetrahedral, 109.5 degree, trigonal bipyramidal, 90 degree, on top to the plane, below to the plane, 90 degree, and between these three on the plane, 120 degree. Octahedral, all 4 on the plane or 90 degree, and the one on top with the plane 90 degree, the one below with the plane also 90 degree.